So we said, first of all, in a right-angled triangle, the square of the hypotenuse equals the sum of the squares of the shorter sides. What would you say about an acute angled triangle? I know you might know the answer, but I want us to investigate this. Right. So I want us now to draw an acute angled triangle. Can I invite you guys, if you have your geometry set, please draw accurately an acute angled triangle. Make sure that you can measure the angles and make sure that you can measure the sides as well. I'll try and draw mine here. Who has finished? Thank you. All right, guys, so we want to investigate the relationship between the sides of an acute angled triangle. In this diagram, I think you all can agree that is an acute angled triangle, right? What is an acute angled triangle? Yes, Andrew?
Triangle with all three angles equal to less than 90 degrees.
Okay, so all the angles should be less than 90 degrees, between 0 and 90 degrees, but obviously they should add up to 180. All right, so that is an acute angled triangle. Which side is the longest there?
B.
It's not B.
It's AC.
It's the side AC, right? It is denoted there by B. Okay, so the length of AC is denoted by B. You will notice this straight away. That is vertex B, and so the length of the opposite side can be denoted by the small letter b. So this is vertex A, then opposite that side is, that angle is BC. So the small letter A is used to denote that. So that is the notation that we use in trigonometry. All right, I need you now to follow these steps here. I'd like you to square the longest side. We cannot refer to it as the hypotenuse, right? So please square the longest side and then square the two other sides and add them, add the results up. Then tell me what conclusion you can reach. Let's use, are you using your triangles?
I'm using it.
You can use mine or you can use yours, okay? The conclusion should be the same. Right, what did you get for the longest side? So 72,11 squared will give us 5,199,8521. Okay, what about the other two sides? Let's start with 63,25. So 63,25, if you square that, you should get, we can round off to 2 decimals, it's okay.
So we get 4,000.
We get 4,000,56, all right. Then the other one is 60 squared. What do we get for 60 squared?
So you get 3,600.
3,600, right? And what is the total of those two? 7,600. 56. Okay, that's fine. Right, so the longest side, if we square the longest side, we get that number there, 5,199. The square of the two other sides, we get that. What can we conclude from here? I know that this is just one experiment. We need to pick as many such triangles as possible and check. Did somebody use their own triangle? Okay, good. We will use that one to compare. What can you say then about the square of the longest side in an acute angled triangle compared to the sum of the squares of the shorter sides? Yes, they're not equal. They're not equal like in Pythagoras' theorem, they're equal, right? Here, they're not equal. What can you say? I'm asking you to look at those numbers, right? And tell me what you can conclude.
So I don't know if it happens in every triangle, but the longest side squared is less than the other two sides.
Okay, do we all see that? Okay, good. Let's write it down. So let's say the square of the longest side is less than the sum of the squares of the other sides, obviously the shorter sides. If you discover that the square of the longest side is less than the sum of the squares of the other sides, then you can conclude and say the triangle is acute angled. Please write down somewhere after this, how else can we recognize an acute angled triangle? If the square of the longest side of a triangle is less than the sum of the squares of the other sides, then that triangle is acute angled.